Good morning, students. Today we start chapter number 10 Science, Light, Reflection and Refraction, in which we discussed about few topics today. Today we discussed reflection of light, types of images, types of mirrors, some definitions related to spherical mirrors, representation of images by spherical mirrors using ray diagrams, uses of concave mirror, uses of convex mirrors. So let's start with the first topic. Ready? Okay. Reflection of light. Reflection of light is what? In a simple manner, we can say that the bouncing back of light is said to be reflection of light. The phenomena of bouncing back of light rays in the same medium on striking a smooth surface is called reflection of light. See in the diagram, there is a smooth surface in which a ray, say this one, is incident on a polished surface. Incident on a polished surface. The ray is striking at point, say O, and reflect back in that direction. That is why the bouncing back of light in the same medium. Say the ray comes from air, striking that point and goes into the same medium, air. So the phenomena is said to be reflection of light. In the same topic, we discussed about laws of reflection. There are two laws of reflection. First one, angle of incidence is always equal to the angle of reflection. This is what? Angle of incidence, and this is what? Angle of reflection. What is angle of incidence and angle of reflection? The angle made between incident ray and normal is said to be angle of incidence, and the angle made between normal and reflected ray is said to be angle of reflection. Second law, the incident ray, reflected ray and the normal at the point of incidence all lie in the same plane. I hope you understand about reflection of light and laws of reflection. Then we move to the next topic. Types of images. There are two types of images: real image and virtual image. Now, one question is to be arise in your mind that what is real image and what is virtual image? If the light coming from a point actually meet after reflection, then the image formed is called a real image. See in the diagram, there are an object, a ray comes parallel to the principal axis, striking to the mirror, and after reflection it will go to the one point C focus in that manner. Another ray which goes to the focus is striking the surface, striking the mirror and reflect back in the same manner. Both the reflected rays will intersect at that point. Is these two rays are actually meet or not? Yes, actually meet. So the image formed is said to be real image. Now next is virtual image. If the light rays coming from a point after reflection does not meet actually, but appears to meet at another point, it seems to be that these two rays appears to meet at another point, then the image formed is called a virtual image. See in the diagram, here an object which is placed on the principal axis in front of convex mirror. First ray which is travel through parallel to the principal axis, after reflection it will go through, it appears that it comes from focal point. Another ray which is travel through pole, it is reflected back with the same angle, it is also extended in the back side. Then these two rays will intersect, but the rays after reflection goes in that manner. So it seems that these two rays comes from that point. So it appears to meet at another point. That's why the image is said to be virtual image, because these rays are not actually meet. Now, next topic is mirror. Mirror is a polished surface. Mirror is a polished surface which reflects almost all the light incident on it. Mirror are of two types. First is plane mirror. What is plane mirror? If the reflecting surface of a mirror is plane, then the mirror is called a plane mirror. So there is what? Reflecting surface of the mirror is plane. A plane surface is said to be what? Plane mirror. Properties of images formed by a plane mirror. First, it is always gives virtual and erect image. We have already seen in the previous slide That what is virtual image? See in that virtual image, it is upright above the principal axis. When an image is above the principal axis, then it is said to be erect image. And when the image is formed below the principal axis, then it is said to be inverted image. Okay, so first is, it is always gives virtual and erect image. Second, the size of image is equal to the size of the object. Means, if the object's height or size is 5 cm, then image is formed by the plane mirror are of same size, 5 cm. Third point, the distance between the image and the mirror is equal to the distance between the object and the mirror. Means, if suppose that you are standing in front of plane mirror, the distance between you and the plane mirror is say 3 feet, then the image formed by the plane mirror, the distance from the image to the plane mirror is also 3 feet. Fourth point, the image is laterally inverted. Laterally inverted. Sometimes when you stand in front of a plane mirror, when you say hello to your image with the left hand, the images shows hello to the right hand. That means left seems to be right and right seems to be left. Uses of plane mirrors. Plane mirrors are commonly used as looking glass in making periscopes, kaleidoscopes, etc. Now, second type of mirror is a spherical mirror. I repeat again. The second type of mirrors is spherical mirrors. If the reflecting surface of the mirror is curved inward or outward, then the mirror is called a spherical mirror. That means if the reflecting surface is spherical, then the mirror is said to be a spherical mirror. Spherical mirrors are of two types. First, the spherical mirror with inward curved reflecting surface converges after reflection from such surfaces, hence it is called convergent mirror or concave mirror. See in that diagram, they are polished in the outer edge. So this inward surface is said to be the reflecting surface. Then it is said to be what? Concave mirror. Now second is convex mirror. If the spherical mirror with outward reflecting surface, see this surface is what? Reflecting surface. And this is what? Outward reflecting surface. Polish is to be done inward. So it is said to be what? Convex mirror. Now, few basic terms related to spherical mirror. First one is principal axis. The line joining the pole and the center of curvature of the spherical mirror is said to be a spherical mirror. Before we start with the basic terms of spherical mirror, I show you a diagram. Here is a hollow sphere. You know that a sphere having a center, say C. When we cut a surface from that and polished on the outer edge, the diagrams look like this. Then the center is lying on that side. If we cut an aperture of that surface and polished inside, then the reflecting surface is this and center of curvature over there. Yes? So principal axis is what? The line joining center and pole is called principal axis. Now, one question is to be in your mind that what is pole? The center point of the reflecting spherical surface is called pole, denoted by P. Third is aperture. The width of the reflecting surface is said to be aperture. The width of the spherical surface, reflecting spherical surface, is said to be aperture. The size is said to be aperture. Fourth, center of curvature. The center of the hollow glass sphere of which the spherical mirror is a part is called as center of curvature. I already shown you that there is a hollow sphere. Here is the center. This mirror is a part of this hollow sphere. So the center of that hollow sphere is said to be center of curvature. Fifth one is radius of curvature. The distance between the pole and the center of curvature. See the distance between pole and center of curvature. This one is said to be radius of curvature and it is denoted by capital R. The radius of a hollow sphere of which the mirror is a part is said to be radius of curvature. Focus point. The point on the principal axis where all parallel rays meet after reflection is called as a principal focus or simply called focus. It is denoted by a letter F. Focal length. The distance between the pole and the focus point. The distance between the pole to focus is said to be focal length and it is denoted by a small letter F. Relationship between focal length and radius of curvature is F is what? F is equals to R by 2. Or you can say that R is what? 2F. Now, representation of images formed by spherical mirrors using ray diagrams. The following ray can be considered for locating the image. You can simply say that the rules for image formation. First rule, the rays coming parallel to the principal axis pass through focus after reflection in concave mirror or appear to come from focus in convex mirror. See the diagram in concave mirror? When rays coming parallel to the principal axis, striking the surface, after reflection it will go through focus. In the convex mirror, when a ray comes incident parallel to the principal axis, after reflection it is also goes to the focus, but after reflection it appears that it comes from focus. It comes from focus. Second law, second rule, the ray coming through the focus of a concave mirror or a convex mirror after reflection become parallel to the principal axis. See, a ray incident to the focus striking the surface, after reflection it will parallel to the principal axis, and in the same manner a ray appears that it comes to the focus, after reflection it will also parallel to the principal axis. Third rule, a ray coming through center of curvature of a concave mirror or toward the direction of center of a convex mirror reflects back along the same path on striking the mirror. There is no change of path when a ray comes or pass through center of curvature, striking the surface and reflect back to the same path. It appears that it goes to the center, striking the surface, reflect back to the same path. Now, fourth rule, a ray incident to the principal axis towards the pole P of a concave mirror or a convex mirror is reflected back by following the laws of reflection, that is angle I is equals to angle R. A ray is incident making an angle, say I, angle of incidence, reflect back with the same angle, say R, and we have already know that angle I is equals to angle R. Uses of concave mirror. Concave mirrors are used in several places. It is used in torches. They are used in headlights of vehicles to send parallel rays to infinite. In shaving mirror to get an enlarged image of the face, and also by dentist to see a large image of tooth or teeth. Uses of convex mirror. It is used in supermarkets and stores for surveillance. It is used as rear view mirror in automobiles. This is due to the reason that a convex mirror provides a wider field of view than a comparison to a plane or a concave mirror. Okay, students, thank you.